Hi, in this video we start to explain some of the alternative methods that we could have multiplied complex numbers and why they don't necessarily work. So what if we defined it pointwise multiplication? So why isn't C a field if we define multiplication to be AB times CD to be equal to ACBD? So since we're just messing around with the multiplication, let's just check the axioms for multiplication to see if we still get a group. So what we're really asking is C without the zero element with multiplication an abelian group? So let's first check out closure. So if we take two complex numbers, multiply them together pointwise, we're just multiplying real numbers in each of the parts, the imaginary component and the real component. So we still get a complex number. It's still closed. Next, let's check the associativity. So again, we're just multiplying associatively within the real numbers. So associativity is going to hold again. Now let's check the next axiom to see if there is a multiplicative identity in this structure. So in our case, we're going to have 1, 1 be the multiplicative identity. And we're just going to go through and check it, and it checks out that we do have an identity. Next, we're going to check inverses. And inverses is where it fails. So if we have 1, 0, for instance, 1 plus 0i, we see that there is no multiplicative inverse. Because if we take any complex number, say a plus bi, or the ordered pair ab, and multiply it, we're going to get a plus 0i, or a0. And we can't rectify having 0 ever be equal to 1 because there is no multiplicative inverse for 0 in the real numbers. And since that fails, the complex numbers with this defined multiplication fails to be a group. And since we have a failure to be an abelian group, we have a failure to be a field. And this is one of the possible ways that we might try to naturally define multiplication, but it turns out it doesn't necessarily work in this instance, and so we're going to have to look at other alternatives to see if we can create a field some other way. Thank you for watching.